Assalamu alaikum wa rahmatullahi wa barakatuh. Now, therefore, today we will discuss about aluminium and magnesium casting alloys. Now, first of all, we should understand what is the alloying principle of aluminium. Aluminium-based alloys generally characterized as eutectic system. Most of the alloying element has less solubility. One aluminum base can contain multiple phases. One aluminum base can contain multiple phases. These phases are soluble at eutectic temperatures. Possible they can be heat treated by heat treatment methods or through aging heat treatment techniques. Now, these are the major alloying elements: copper, silicon, magnesium, zinc, chromium, manganese, titanium. However, iron is usually considered as impurities. Now, first of all, let us discuss about aluminium. Now, this is the equilibrium diagram of aluminium copper system. Now, here it is eutectic composition, which is having a maximum solubility at 548 degrees centigrade. It is about the 5 point. This is the it is about 15.6%, and it is 85% at room temperature. You see, it is 5%, 0.5% at room temperature. Now, macrostructure at any temperature, at any temperature, see, is theta. Composition of theta phase is cupric aluminide, which is having 46.5% copper and 53.5% aluminium. It is a hard phase. Therefore, with increase in hardness will increase the to increase the hardness, we have to increase the theta phase in the alloy system. Now, this gives that what is the ratio of different aluminium, copper, aluminium system. See, now this gives the strength with respect to the aluminium content, with respect to aluminium content, that of aluminium copper alloy. With increase in aluminium, the strength has increased to a maximum and then decreases. Therefore, solid solution phase is soft, ductile. Hardness and strength increases with increase in this alpha phase that given in previous phase diagram, that is soft. But with the increase in delta phase, you can see the strength has got enhanced. Hence, actual amount of copper in alloy is 2 to 5%. Now, heat treatment of copper, aluminum copper alloy, as we have seen that solution heat treatment, that is heating to elevated temperature and rapid cooling, or by using chill casting, whether it is by using permanent mold, we can achieve steel casting, and then you will see that the alloy get hardened. It can, this hardening can be done by having edge hardening, that is increasing in hardness with lapse of time. Now after some time, when the percentage of copper is 4% and 96% is aluminum, heated to 150 degrees centigrade to 200 centigrade, in that the range, in that range, you will see that they get alpha phase, they convert into alpha phase, and then certain cooling cause to convert to precipitate this beta phase, which is the hardened phase. But with lapse of time, these phases just segregate, and we call over-aging. That decreases segregation of that delta phase, of course, will decrease the strength of the alloy. Now silicon. Silicon again, this is the alpha phase. Solubility is very small, and it is up to 14% we can go for alloying silicon. Now solubility in silicon of silicon aluminum is 0.05% at room temperature, but and it is alpha phase up to 577 degrees centigrade. Undissolved beta phase is extremely small. Beta phase here, we can say it is extremely small percentage of aluminum. Now, increasing silicon content will increase the hardness up to eutectic composition. However, ductility, when hardness is increased, ductility is reduced. More coarse particle occurs in sand casting, and the grain refinement can be achieved by chilling effect in permanent mold or in die casting. Some special casting processes can be also adopted to control the grain refinement. Now this is magnesium. Now alloying behavior is very similar to copper. Now you can see here again, as similar to copper, it is having soft alpha phase, and here we are having a beta phase. Now therefore it is soluble up to 14.9% at 450 degrees centigrade. But at room temperature, this beta phase is harder. Therefore, by having a possible heat treatment, maybe solution hardening similar to that copper, we can develop this beta phase. The amount of beta phase will give the hardness. However, aging, precipitation hardening, aging heat treatment can be done. Moreover, by adding some other alloys, we can form a complex alloy and improve the property of aluminum. Now magnesium and silicon. Now the both magnesium has got its own effect on alloy, on aluminum alloy. Silicon also gives its own. But when we have a complex system of magnesium silicon in aluminum, we are having the soft phase, and then aluminum silicon, they are being mixed, and this is a very hard phase. You are having this phase is hardened again. It is enhanced by using a complex system. It has an important alloying effect on aluminum and formation of this magnesium silicide, a quasi-binary alloy system, and this causes hardening effect. This magnesium silicide and they permit solution treatment, age treatment. Therefore, the composition in this magnesium, silicon in aluminum is magnesium up to 0.3% and silicon up to 6 to 8%. Excess silicon improves casting properties also. Now next is zinc. It is having beneficial effect to obtain maximum mechanical properties as cast condition. As cast condition. There are other alloying elements. They include lead, tin, antimony, arsenic, cadmium, etc. They enhance, depending upon the properties, they enhance some other properties like lead increase machinability of the alloy. Similarly, tin and others, they have got its effect, but they are limited up to 0.05 to 0.1% only for alloying. Then we can have, as we have talked about, silicon, magnesium. Similarly, we can enhance the property of aluminum alloy by having a complex alloying system, which can be achieved to improve strength, hardness, response to heat treatment, etc., etc. And therefore, we can have, as we have seen, copper, magnesium, zinc in aluminum alloys, and also magnesium and silicon in as I've seen. Similarly, we can have different complex system, and we can we can have different property according to our tailored property according to our requirement. However, the excess of amount of all these in the complex system loses ductility and toughness. Therefore, we have to make a compromise. However, the commercial alloys are having a complex composition. Now, however, these are certain impurities which affects the alloying system and seriously impaired alloy characteristic like ductility, toughness, corrosion resistance. However, some of the impurities are excess of silicon. Silicon is having a good impact on a alloying system, but excess of silicon acts as an impurity. Iron, as we know, that it can up to 0.8 to 2% pick up from the furnace pot itself. If it is a steel pot, then iron pickup is always there. Now this iron acts as a impurity because it causes embrittlement and loses current resistance. Moreover, due to iron, the grain size get coarsened. Now, zinc in excess loses corrosive resistance, and therefore we have to limit or control the content of the zinc. This is all about the alloying element and alloying system of aluminum alloys. Thank you.